Hello there and welcome back to another CPD talk. My name is Jasmine. I am the senior in blood transfusion and the training lead for NKPS. Today we're going to be going through blood grouping systems. Isn't that just ABO? What we're going to cover is what a blood grouping system is, what makes a blood grouping system a system, how many there are and what their names are, which ones are routinely used, how does this understanding give us an advantage, and then I'm going to use P1PK as an example. So what is a blood grouping system? A lot of people, when you say blood group system or a blood group, you immediately think of ABO because that is the main blood group that we look at. And the ABO blood group is the first blood grouping system. However, there are actually over 40 blood grouping systems. And what a blood group system, I apologise, I'm going to say that a lot, is one or more blood group antigens. So you could have one in a blood grouping system, or you could have 50, which are all encoded by either a single gene or by a cluster of two or more closely linked homologous genes. And you can see here there's just an example of some of the different blood groups on the red blood cells and how their antigens are structured. It's a nice picture. So what makes a blood grouping system a system? So as I said, because all of the antigens within the system will be coded for by one or several closely linked genes, it will mean that they will all have similar properties and reactions. Now, this doesn't necessarily mean that they will have similar properties when we're looking at them from the blood transfusion point of view, but you have to remember when you've got an antigen, although we're looking at how it's going to impact in terms of a transfusion reaction, that antigen will have its own unique properties within the body. So it might be associated to certain diseases, it might let certain things cross the cell membrane, and therefore what you'll find is depending on which antigen mutation a person has present on their red blood cells, it might change how that person is going to react in different circumstances. So for example, in the Indian blood group, they're all on a specific CD marker. The fact that they are all related and structured in the way that they are means that although the majority of them can cause a transfusion reaction, they don't cause hemolytic disease of the newborn normally, because the actual antigen binds to lymphocytes and monocytes, and therefore when it crosses the placenta binds to these cells before an immune response can be mounted against it. As well as this, it generally means that the antibodies that are directed against these antigens will have similar properties, right? Because they're going to be of a similar structure. Not the exact same structure, but they will be similar. And obviously this will vary depending on how big a blood grouping system is. If you've got a blood grouping system with over 50 antigens in it, then there's going to be a bigger variance than there will be with one that has 5 antigens in it. So you have to bear that in mind as well. How many are there? What are their names? So, as with all of science, this part is constantly changing. When I last checked it, there were 43 blood grouping systems, but I have a textbook that says that there are only 30 something. You have to remember that as we get better and more advanced, we're going to be able to see things that we couldn't originally see. So there are also antigens that have been moved from different systems as we've discovered more about them. So for example, I recently put up a talk on nomenclature, and I said that the Rh blood grouping system has 55 antigens present. But when you look at how it's named, it goes into the 60s because some of the antigens that were originally assigned part of that blood grouping system have been taken out and have been moved elsewhere, or have been decided that they're not proper antigens. So it's an evolving topic, and I recommend that when you are actually listening to this, you go and check the ISBT website to see how many blood grouping systems there are at the moment. Because I wrote this in May, I'm recording it in June. This is probably going to come out end of June, early July, because I've got 2 other talks that are predate this one coming out. And things change really quickly. So it's a good thing to be aware of and to keep informed about. So I've now got the table. This is from the ISBT's website. I'm not going to sit here and read them all through because honestly that's so boring. But what I will do is just go through one of the rows just to explain what we're looking at here, right? So the first column is basically the number that's assigned to that blood grouping system by the ISBT. So not surprisingly, the ABO system is number 1, right? You've then got the original system name and their full name, so like Lutheran, the RH, Lewis, Duffy, etc. And the next one is the system symbol. So this is a symbol that will often denote it, whether that be in books or papers, and it will normally be used as well when talking about the genetics involved. You've then got the gene name or names. So you can see that with the majority of these, there's only 1 gene per blood grouping system. There are some exceptions. So for example, in the MNNS, you've got 2, and then the third one there is just one that when it mutates can have an effect on some of the antigens, but doesn't specifically code for the antigens, and that's why it's in brackets. The other one, which is a bit better known, is for the RH blood grouping system, because you've got RHD, which codes RHD, and then you've got RHCE, so that's a joint gene that will code for big C, big E, little c, little e, etc. You've then got the number of antigens in that system, the chromosomal location, and the CD numbers. So that'll be what CD relates to it. Some blood grouping systems won't have that. So if we have a look on this page, we've got 18, and then on the final page it goes all the way to 43. Another thing that's a nice thing to note is if we go back to the beginning, you can see the majority of the systems on this page have several antigens within them. But when we get to the end, there's only 1 or 2 present, and that's just because we're only just discovering them, right? So as we discover more and more, there'll probably be more antigens put into that system, but currently these are the only ones that we found, and they're what have been put in. So what you might find, say you look at this in a month or 2's time, it will have the same amount of blood grouping systems, but there'll be more antigens, or the antigen numbers will have changed because they moved from one system to another system. So which ones are routinely described? Ideally, I am going to try to do a presentation based on each of the common blood group systems. And these are the ones that are normally represented on panel sheets within the laboratory, and that most people who work in the sciences are aware of. So they would include obviously ABO, MNS, P1PK, RH, Lutheran, Kell, Lewis, Duffy and KID. So I'm hoping that we will have talks on most of these. However, obviously depending on where you work, so which country you're in, will alter which blood grouping antigens / antibodies you're more likely to see in your population. So that's just something to note. So how does this understanding of blood grouping systems give us an advantage in the laboratory? What I'm going to do today is I'm going to use P1PK because it's quite a small blood grouping system, so it will be a very, very quick talk for me to do, just to demonstrate how important it is to have the understanding of blood grouping systems. The P1PK blood grouping system specifically describes antigens coded for by the 22q13.2 chromosome, which is called A4-GALT. There are 3 antigens within this blood group. P1, which is the one that you will see on our panel sheets currently, which is the polymorphic antigen. PK, which is high prevalence, that means over 99% of the population have it on their red blood cells, and NOR, which is low prevalence, which means that less than 1% of the population have the antigen on their red blood cells. Just to make it clear, if I say P1, etc., I'm talking about the antigen. If I say anti-P1, I'm talking about the antibody. This system is obviously one of the smaller systems. There are only 3 antigens within it. Therefore, there are a lot more similarities between these than there might be in one that's got more antigens present. So, for example, antigens are resistant to enzyme treatment, so they'll be enhanced by enzyme on the panel. So you can see already how that could help to influence your work in the lab. Anti-P1, so this is the antibody, it's normally IgM, however can be IgG. So routinely you would expect it to be IgM, in which case it wouldn't be picked up in our normal panels because we incubate them. However, on occasions it can be present as an IgG antibody. And because of this, its optimal temperature is room temperature, because IgM works better at room temperature. It rarely binds to complement, and therefore will only cause moderate transfusion reactions, which are normally delayed. However, they're rare because normally, not always, but normally the delayed transfusion reactions are due to IgG. It's rare to have anti-P1 as an IgG antibody. And as it's normally IgM, it shouldn't cross the placenta, so HDFN, very, very rare. Anti-PK can be both IgM and IgG, and it's not as rare for it to be IgG, so it can just be either. So that can react at both room temperature and 37 degrees, depending on the antibody type. Unlike anti-P1, it can bind to complement, so it can cause severe transfusion reactions. But again, this is rare. It can also cause severe HDFN because it's more likely to be IgG and therefore cross the placenta. Finally, anti-NOR, only been found in a couple of people. This is probably due to the fact that it is a low, NOR itself is a low incidence antigen. Therefore, very few people in the population will have it on their red blood cells. So the chances of a patient having a sensitizing event to it are very unlikely. And even if they were to have a sensitizing event, the chances of us then picking that up in the laboratory is even more unlikely. Especially as most of the case that has been found, the antibody has been IgM, so we wouldn't pick it up routinely in our testing. So there's not really any data of clinical significance. Previously, that the blood group systems were normally very similar in their expression, yet here there can be vast differences between the individual antigens/antibodies. How is this information actually helpful? It has been shown that antigens in this group react by enzyme and are able to be, if not are more likely to be, IgM antibodies. So where this information could be useful. If you're looking at a possible new antibody, if it's reactive at room temperature and appears to be reactive in enzyme, then you can look at setting it up against cells which are negative for blood group antigens which react that way. Next, if you have a panel which you're struggling to identify an antibody, knowing that the P1 PK should react a blood group system should react an enzyme means that if there is not a reaction, it will be highly unlikely that this patient has an antibody from this group. Finally, having an idea of the clinical significance can be important. All of the antibodies that correspond to antigens within the system are capable of causing a transfusion reaction, whilst albeit is rare, and therefore you should be taking that into account. So while it's not essential to know the ins and outs of each blood group, it does help inform your practice, and obviously depending on the blood group that you're looking at, like the blood grouping system, that will alter the relevance of the information. At the very least, knowing which system the antibody/antigen that you're looking at would belong to will allow you to look it up with a lot more ease than not knowing where that antigen antibody comes from. and then you should be able to find out more information about it. If you were to do a Google search for anti-NOR, for example, you're probably not going to bring up very much information because it's not a normal search for people to do. So whereas if you were to look at the P1PK blood grouping system, you're more likely to get references to anti-NOR that you can follow through on. That's about it. Hopefully this has been an interesting talk for you, and it's helped with the understanding of what blood grouping systems actually are. The next talk that we're going to do is going to be on the MNNS blood grouping system, which is one of the biggest blood grouping systems that there is. So that one's going to be a lot more in depth and have a lot more information in it than the P1PK system did. If you do have any questions, then please feel free to contact myself, and please remember to do a reflective learning to make this a robust piece of work. Thank you so much for listening. Bye!